Hi there. Today I'll be talking about something I've been playing around with for a little bit, and I titled it AI Labs, for lack of a better title, quick demo and architecture cheat sheets. And then maybe the subtitle would appeal to small and medium business owners. Hone your AI, private, fast, predictable cost LLMs for SMEs, ChatGPT styles on your hardware with your own data, emphasis on that. So the audience will probably be for to the AI engineering team, ML ops, DevOps, and SMB owners. So brief introduction. AI Labs is a local LLM inference server. It exposes open AI compatible endpoints, chat completion, embedding, similarities for easy integration. It ships a polished CLI interactive chat UI for rapid experimentation because I didn't want to bother about building a proper front end and all of that, web based and all that. So it's just a simple terminal UI. And then it has a simple finance retrieval RAG over data transaction CSV for instant answers to transaction queries. So my stack choice and why. So I chose to use PyTorch and Hugging Face Transformers. It's got widest model coverage. So there's a lot of models on Hugging Face. And then I also chose to use FastAPI and UVCon because it's pretty fast, async by default. It's great for developer economics and allows streaming and all of those things. Sentence transformers, and then also a rich terminal UI, which I mentioned earlier, which is just like a simple UI to just test run this, and then you can later outsource the building of the proper web UI to like a front end person. And then pandas for lightweight analytics over the CSV data, which I would show us, and then UV basically for fast installs and access to latest CUDA kernels because I'm running an NVIDIA GPU. So design principles really OpenAI compatibility first to reduce integration friction, single process model cache with optional preload for fast token latency. And then it's GPU first. Might fall back to CPU, but I haven't really tested that. Basic hardware requirements. So OS, Linux is recommended. I'm not sure if it's going to work with that. Yeah, but I work with Windows on WSL. GPU mostly recommended, and then NVIDIA GPU recommended. Disk size maybe 10 to 20 GB should be good for the model and all of those things because I'm using in this one I'll use tiny llama, but then in my other test I use some other 7 billion parameter model. And then Docker if you want to implement the Docker part for when you want to take it through like the ML up cycle and all of that. One quick question really. I'll quickly go through like the demo, then I'll come back to some of the reasons why I made like some of those decision choices and this. So let's see how that would go. So I'm connected to my server, which is running Arch Linux, and then so I can like check the what's it called, the configuration on the system, so we can see it's AMD Ryzen 7. But of importance is the fact that yeah, it's got like an NVIDIA GPU RTX 5080, so that would be good enough to run like any of the workload or at least some of the workload that I want to run. So let's just quickly, if it's not synced before, you need to run UVSync to sync all the Python dependencies, but I've already done all that. So I will just run the terminal chat UI, and yeah, that would drop us into like the terminal UI. Here allows just like a basic terminal UI interface for us to interact with the large language model. Currently, I'm using Tiny Llama so that we can get like speedy response, but I could as well use like a 7 billion parameter, at least on my hardware. And then if you have a better hardware, of course, you can use something even much more serious. So I can just say, howdy, who are you? And that's like a regular question. The streams that it says I'm a virtual assistant that opens and uses algorithm, blah blah blah. I say a summary of the tokens generated and all that. But then let's go to like a bit of the RAG specific questions that has to deal with transaction data. So I can say, for instance, what was my largest expense? And then it goes ahead and say your largest expense was 1,000 this blah blah blah, and it was on a Neptune HX 1000 blah blah blah. So if I go like into the data that was fed into the RAG portion, yeah, I might need Rainbow CSV. Let me just quickly drop that in so that I can make the view a bit better. So yep, we can see like this. So we can see like, yeah, truly this was like is 1,295.83, just like you mentioned, and then it was on that particular day and all of that. And then it's got like a smart interface where it knows a smart routing interface where it knows when to route inquiries directly to the RAG for quick response and accurate response, and he knows when to go back to like the actual large language model for general response. So for instance, let's just say explain LLMs briefly with examples. And then it goes ahead, so he knows this is not being routed to the RAG, but then it's going directly to the LLM to get us what we need to do. So that's kind of like the quick summary. I can just exit, and if I want to save the chat conversation, I can say yes. If I say yes, then I don't need to give it a title, it's optional. Then I can just save it and then it's saved somewhere there. So now I'll quickly run back to like the few things I was talking about. So my design principle was really OpenAI compatibility first, so that this can be it can be easily integrated to whatever existing system that needs to use this. And then if you need to switch back to like OpenAI or pretty much any other one, you can easily switch because it's similar to the endpoints. You only probably need to change the base URL, and then it's GPU first. It streams the response, and yeah, hardware requirement. I think I mentioned that the other time. So yeah, why transformers instead of using Olama? Because you might say, okay, why don't I just use Olama for this? Flexible control, because you can load any Hugging Face repo, full access to tokenization, decoding, chart templates, and all of that, mix generation, and same all of that good thing and all that. So you have access even to a lot more models. So if for instance we go to like Hugging Face website, you have access to pretty much a whole lot of models compared to what you would have access to on like Olama. And then so it gives you flexibility and control over your large language model in terms of training it, retraining it, in terms of extending it really. And then you have ability to customize your own API around your model. So for instance, I'm using FastAPI and I can customize it however I want it to make it OpenAI compatible and all of that. Easy metrics and all of those things. Integrations are very seamless. And then Olama is just really quick, good for like quick basic setup. But when you want to look for something long term and more usable for business, then this might be a better fit and all of that. And yeah, so it's got a couple of use cases. So you can have like financial operation, instant spending analysis, customer support, document automation, engineering productivity. One of the major benefits really would be data residency and private. Your data is private as long as you have the hardware, and then you keep your data private and all of that. And then cost control also, you can predict your cost, which is basically just the bill that you incur from the ownership of your hardware and maybe power bills and all of that. It's customizable. Latency is low, at least for like some basic things. And then the integration, the OpenAI compatibility and all that. And then it's vendor neutral. You are not tied into a particular provider. And then you can really run through it. So that's really what I wanted to talk about. The repo is made available and then it's open sourced. So if I go to like on GitHub, it's called AI Lab, and if I zoom that a little bit, yeah, it's called OpenAI AI Lab and all of that. I would also link it in the description of the video. Thank you for watching, and I'll probably see you on the next one. Bye for now.